Question 1. Through the lens of advanced acceleration and performance tuning, ISTA Ahmed administers a high-traffic checkpoint security gateway running CoreXL and SecureXL. Suddenly, encrypted traffic shows no signs of acceleration and CPU utilization is abnormally high. He suspects misalignment between acceleration and CPU queue binding. He inspects FWAXL output and sees encrypted sessions marked as non-accelerated. What should ISTA do to ensure encrypted sessions benefit from the SecureXL acceleration path? A. Rebind the encrypted packet processing to existing accelerated CPU queues. Enable FWAXL debug to monitor SecureXL path. B. Disable SecureXL and rely solely on CoreXL for encrypted traffic. C. Reinstall the Security Gateway OS to reset SecureXL configuration. D. Redirect encrypted traffic to dedicated physical interface to bypass SecureXL. Answer. Correct answer. An explanation. To re-enable acceleration for encrypted sessions, you must bin CPU cores used for SecureXL acceleration to process encrypted packets. Using FWAXL debug helps verify that sessions traverse the SecureXL path. Disabling SecureXL B removes the performance benefit. Reinstalling OS C is overkill and unnecessary. Redirecting via separate interface D doesn't address core acceleration binding. The correct approach. Align CU core binding with SecureXL, monitor via FWAXL debug, and ensure encrypted traffic remains in accelerated path. Question 2. When considering advanced ClusterXL troubleshooting, is Priya overseas? A ClusterXL high availability pair experiencing intermittent split brain events during high load. She notices state synchronization fails when cluster members are under heavy VPN tunnel throughput. She suspects delayed or dropped synchronization messages. What conceptually best addresses this root problem? Optimize sync interface MTU and latency, ensure CCP heartbeats aren't dropped under load. B. Increase log server verbosity to capture hard details. C. Disable VPN tunnels during high load periods. D. Remove SecureXL to simplify cluster messaging. Answer. Correct answer A. Explanation. Split brain often happens where CCP heartbeats or state synchronization messages are lost or delayed. Optimizing NTU, latency, and ensuring reliable sync channels. Specific sync interfaces mitigate this increase in logs. B helps diagnostics but doesn't fix messaging reliability. Disabling VPN-SC circumvents, not resolves, the issue. Removing SecureXL D doesn't directly impact CCP messaging. Root cause, synchronization path reliability under load. Question 3. Under the assumption that interpret outputs from various debugging tools to identify root causes is to both run FWUnit to trace the drop packet caused by a NAT misconfiguration, but the output is overwhelming. He needs to filter only packets matching the specific source port and destination IP, which technique allows fine-tuning this filter A. UFWUnit. B. Set C equals ESD equals sport equals dport equals with packet captures limited to those parameters. B. IPFWUnit output to grep after full capture without pre-filter. C. Capture everything and manually review in Wireshark. D. Redirect traffic through TCE dump for easier analysis. Answer. Correct answer A. Explanation. The power for FWUnit. The expression filter enables capturing only packets matching specified criteria. Desiate ports, dramatically reducing noise and improving focus. Piping to grep. B is inefficient and may miss patterns. Manually reviewing all packets. C is time consuming. Using ECE dump. D isn't as precise for checkpoint internal packet traversal debugging. Concept. Apply advanced filtering with FWUnit. Question 4. In the context of troubleshooting management processes, Zhang observes that policy installations from Smart Console hang indefinitely and Nidaluya an AIM management server has high EPU consumption. She wants to diagnose whether the culprit is a leader. What should she investigate to decide? A. Check EPD logs EPD elg for broker connection errors elg for policy compilation delays. B. Reboot the management server to clear potential deadlocks. C. Disable and force EPD to perform installations. D. Flush the policy cache on the gateway manually. Answer. Correct answer A. Explanation Edelo handles policy computations. E. Integes broker communications. Investigating FDLA logs reveals policy compilation or hanging issues. E. Gamay show connection or handshake failures. checking logs pinpoints weather policy, install HOTS dual overloader CPD issues, rebooting. B is disruptive, dislift alert. C breaks functionality, flushing gateway policy cache. D doesn't address management server internal delays. Question 5. Based on the information, Mr. Santos is troubleshooting a packet dropped at kernel level due to NAT misalignment. He wants to trace NAT translations and firewall chains interactions. Which command best reveals both NAT and filter rules? Traversal. A FWiniter. Accept, analyze the raw trace and manually map NAT steps. B really drop to C kernel drops including NAT. C USEF or monitor. E NAT then separate FWiniter. Drop. D use combined filler FWiniter. Accept or reject or NAT to view both NAT and chain flow. Answer. Correct answer, D explanation. A combined expression capturing NAT and accept reject events lets you follow NAT transformation and firewall decisions in one trace. Separating captures. C fragments the faux FWiniter. Accept alone. A misses NAT. The drop. B shows drops but not NAT traversal. The concept, consolidate filter expression to trace transformations and filtering in unified context. Question 6. Considering the evidence Lee relies on CFAPROB state and CFAPROB SN to analyze cluster health. She sees member states mismatched though network looks healthy. She suspects sync packets are processed slowly due to kernel scheduler overload. What's the conceptually correct high-level action? A. Prioritize cluster control interrupts by enabling real-time kernel scheduling, tuning, and reducing other user space load. B. Disable logging temporarily to reduce load. C. Move cluster members to separate management interfaces. D. Restart CFAPROB to clear its state. Answer. Correct answer. A. Explanation. When the kernel is overloaded, control plane packets CCP state sync can be delayed. Tuning kernel scheduler to prioritize cluster control interrupts and offloading user space load ensures timely synchronization. Disabling logging. B. May help but is ad hoc. Changing interfaces. C. May isolate traffic but not scheduling delays. Restarting CFAPROB. D. Is superficial. Root cause remains. Question 7. From a practical standpoint, Mr. Mullo is seeing like Phase 2 negotiation fail. No proposals chosen with a site-to-site VPN tunnel. Log files show mismatched encryption algorithms. He wants to test various proposals quickly. What approach aligns best with underlying ICIPSEC principles? A. Configure overlapping proposal sets. G. Multiple acceptable encryption algorithms on both peers to maximize match chances. B. Force single highest strength cipher only on one side. C. Disable encryption until tunnel comes up, then re-enable. D. Use different proposals for Phase 1 and Phase 2. Answer. Correct answer. A. Explanation. Like negotiation succeeds when both sides share at least one common proposal. Offering multiple acceptable cipher options increases likelihood of match and tunnel establishment. Forcing one. B. Risks mismatch. Disabling encryption. C. Is insecure. Using different proposals. Phase 1. 2. D. Is valid, but the core is offering overlapping sets. Underlying concept. Negotiation flexibility eases matching. Question 8. Within the framework of advanced FWiniter filtering and inspection techniques, is Nakamura targets only packets that hit a custom drop action in an application control blade. She needs to capture only those to pinpoint risk classification. Which filtering approach is conceptually most precise? A. UFWiniter. B. Denny ID app drop. Stars to catch packets dropped by application control. B. Run and limit FWiniter and manually scan. C. UEC dump filter for application signatures. D. Disable application control and test again. Answer. Correct answer. A. Explanation. Using the deny ID expression with FWiniter to pinpoint application control drops precisely. Manual scanning. B. Is inefficient. EE dump. C. Lacks application control identity. Disabling application control. D. Avoids the issue instead of diagnosing it. The conceptual point. Apply targeted filter expression to isolate specific blade actions. Question 9. In live recent developments, Mr. Rossi observes the Gaia OS kernel panicking under heavy connection load, suspected due to kernel memory allocation exhaustion. He wants to monitor memory usage by internal firewall kernels in real time to spot leaks. What's the conceptually sound command? A. URL stat and top to correlate FWRNL memory stats and process memory in real time. B. Rely solely on system logs after crash. C. Schedule nightly reboots to clear memory. D. Disable SecureXL to reduce memory footprint. Answer. Correct answer A. Explanation OELStat provides kernel-specific memory and connection stats. The top shows process-level memory usage. Correlating both helps identify memory leaks or exhausted kernels in real time. Logs B are post-mortem. Scheduled reboots C are mitigation, not resolution. Disabling SecureXL D may shift memory behavior but not pinpoint leak. Concept: combine kernel level and OL level tools by diagnostics. Question 10. The fundamental question is Mr. Chahiri tries to perform health checks on both a security gateway and its corresponding management server. He must validate connectivity, process health, and synchronization integrity. Conceptually, which sequence of checks is most effective? A. Ping gateway from management, check EED dedale OSSs, validate policy installation and mdmi show objects consistency. B. Run top command on both and restart any high EPU processes. C. Only test policy, push from Smart Console. D. Remove and re-add the gateway object in the management topology. Answer. Correct answer A. Explanation. A systematic health check includes connectivity test, ping verifying key management process EDA, ensuring policy install path is healthy, and checking that objects configured are consistently represented in MDMI show objects. Using top B gives performance view only. Policy push alone. C may miss process level issues. Removing and re-adding D is extreme and disruptive. Underlying concept, methodical multi-layer validation. Question 11. Across different scenarios, Velasquez manages multiple clusters in HUM mode using ClusterXL. During a failover simulation, she notices the backup member remains, initializing longer than expected. The CFAP output shows heartbeat communication, but state sync fails. Upon checking, she finds full disk usage on the sync interface. What should she do to resolve the delay? A. Lower the priority of non-critical sync messages UI or FITI. B. Enable aggressive aging on sync interface to free bandwidth. C. Clear disk space or migrate sync interface to another dedicated interface. D. Reconfigure CCP to use unicast instead of multicast. Answer. Correct answer. C. Explanation. A full disk or overutilized sync interface can prevent ClusterXL from exchanging synchronization data, leading to a prolonged initializing the state. Moving sync traffic to a dedicated interface or clearing disk congestion solves the core issue. Option A is irrelevant. A. Manage CPU binding, not sync priorities. Aggressive aging. B. Affects connection tracking, not disk IO. Changing CCP to unicast. D. Doesn't address disk usage. Question 12. To better understand unexpected policy installation failures, Novik investigates logs revealing Smart Defense configuration error and finds multiple failed validations in the Smart Console. He suspects database corruption after an incomplete jumbo hotfix installation. Which action best targets resolution while preserving configuration? A. Reset Smart Console and restart the delay. B. Debivert and upgrade export to export, then re-import after rollback. C. Rebuild the management server from scratch and reconfigure objects. D. Flush IP signatures and continue with policy installation. Answer. Correct answer. B. Explanation. Using upgrade export and EBVO ensures you retain configuration and version compatibility while rolling back or rebuilding the database. Rebuilding from scratch, C, is time-consuming and risky. Resetting Smart Console A affects only the GUI, not corruption. Flushing IP signatures, D, bypasses the issue rather than fixing corruption. Exporting and restoring is the safest structured resolution method. Question 13. When analyzing packet drops at the kernel level, Mr. Gomez discovers legitimate HE per traffic being dropped without a log entry. UI drop and observes reason violated internal buffer consistency check. What is the root cause likely tied to? A. Network address translation timeout conflict. B. An internal memory corruption or buffer overrun issue in the kernel. C. Wrong policy package installed on the wrong gateway. D. Time zone mismatch between Smart Console and gateway. Answer. Correct answer. B. Explanation. The message points to kernel-level buffer integrity issues, often due to memory exhaustion, overflows, or bugs in driver kernel code. NAT timeout 8 would show different errors. Installing the wrong policy, C, may cause drop, but it's not tied to buffer checks. Time zone mismatch, D, causes log confusion, not drops. Solution, investigate system resources, patch levels, and driver compatibility. Question 14. Examining the consequences of improper SecureXL configuration, Carter finds that while SecureXL is enabled, traffic is still being handled in the slow path. The command fwaxl stat shows accelerate PATS 0. What is the most probable explanation? A. The inspection policy contains rules that disable acceleration due to content inspection. B. SecureXL kernel module is not loaded. It needs manual moprobe. C. CoreXL is incorrectly configured, causing it to override SecureXL. D. Physical NICs used do not support acceleration. Answer. Correct answer A. Explanation. SecureXL works only for traffic that matches acceleration-friendly rule paths. Deep inspection features like IPS or application control for slow path traversal. Kernel module absence. B would show module errors. CoreXL C and SecureXL are complementary, not conflicting. NIC acceleration D isn't required unless using specific offload modes. Best fix. Refine policy to allow acceleration. Question 15. In a modern context of VPN troubleshooting, Camel received reports that only specific remote users are unable to connect via remote access VPN. They authenticate successfully, but packets never reach the internal network. Packet capture reveals that NAT is incorrectly applied. What is the best step to fix this? A. Change user access roles in Smart Dashboard. B. Add a manual NAT rule above the auto-generated ones, matching source, user group, and target network. C. Delete the VPN community and recreate with new rules. D. Restart the VPN daemon. Answer. Correct answer. B. Explanation. When AutoNAT doesn't work correctly for certain users or destinations, adding a manual NAT rule above the auto-generated ones ensures the correct translation. Role changes A. Effect access control, not NAT. Recreating the VPN community. C is extreme. Restarting EPND. D doesn't change policy behavior. A manual NAT rules offer granular control needed in this case. Question 16. From multiple perspectives, is Renat a suspect's packet loss due to a mismatch between SecureXL's acceleration path and IPS protections? After running fwaxl stats and IPSOF, performance improves dramatically. What should she investigate to balance security and performance? A. Ensure all IPS protections are enabled globally. B. Tune IPS profiles and enable bypass under load. C. Disable SecureXL permanently. D. Limit CoreXL to 2 CPU cores for better focus. Answer. Correct answer. B. Explanation. High IPS load can force haul traffic to slow path, tuning IPS profiles. E.g. disabling unnecessary protections and enabling bypass under load allows critical traffic to continue under high usage. Option A increases load. Disabling SecureXL. C. Sacrifices performance. Reducing core access. C+. D. Reduces scalability. Concept. Performance tuning must balance inspection versus throughput. Question 17. The core principles of kernel debugging are applied by Taleb, who traces a packet from pre-routing to post-routing UFW, so he expects 4 inspection points but sees only 2. I know. What best explains this behavior? A. Packet was handled entirely in the slow path, skipping proposed processing. B. Firewall drops the packet between outbound and post-routing. C. SecureXL offloaded the packet, so only INO appear. D. Interface mirroring was enabled, hiding pre-post chains. Answer. Correct answer. C. Explanation. When SecureXL accelerates traffic, it bypasses parts of FWUnit chains, like INO showing only INO. Option A is inaccurate. Slow path still shows all chains. Drop outbound. B would result in drop log mirroring. D. Affect switch behavior. No FWUnit chain visibility. Key point. Acceleration short circuits the inspection chains. Question 18. Historically speaking, NAT table corruption led to traffic anomalies in older builds of checkpoint. Is the Rosen URL debug MNAT or notices malformed entries? What is the best approach to restore NAT functionality without full gateway reboot? A. Restart only the AWL module. B. Flush the NAT table and allow recreation using FWP. AWSL. X. C. Clear the routing table and restart all daemons. D. Force a manual policy uninstall and reinstall. Answer. Correct answer. B. Explanation. Flushing the NAT allocation table allows the gateway to recreate mappings based on current policy. Restarting the kernel may cause downtime. Clearing routing table. C. Disrupt all traffic. Policy uninstall. D. Is high risk. The correct fix targets the NAT allocation table, which is dynamic and safe to flush. Question 19. Through careful analysis of daemon behavior, Laurent identifies that the Babluda OS crashes intermittently, interrupting log delivery to Smart Console. He suspects high log volume overwhelms the daemon. What action can prevent further crashes while retaining logs? Disable logs temporarily until volume reduces. B. Increase buffer size and split logging to multiple destinations using log exporter. C. Replace Babluda with a backup version. D. Limit logging by turning off rule hit counters. Answer. Correct answer. B. Explanation. Increasing log buffers and using log exporter to distribute logs across syslog servers prevents overload and disabling logs. A. Is not viable for production. Replacing binaries. C. Is unsupported and risky. Rule hit counters. D. Don't affect the ability. Structured log management prevents daemon crashes due to volume spikes. Question 20. The interrelationship between policy and kernel visibility is critical in debugging. Ismorin modifies stealth rules and installs a policy. Suddenly SSH access to the gateway fails. She cannot reach the client remotely. What's the likely cause? A. Anti-spoofing was auto-enabled and blocked her IP. B. A stealth rule mistakenly blocks SSH to the gateway itself. C. The management server blocked all outbound traffic. D. SecureXL filtered packets before reaching firewall chain. Answer. Correct answer. B. Explanation. A misconfigured stealth rule can block SSH to the gateway, which is a common pitfall. Stealth rules apply to the gateway itself and may override access rules. Anti-spoofing A would show in logs. The management server C does not affect inbound gateway SSH. SecureXL D does not block traffic by itself. A policy determines action. Always double-check stealth rules to avoid cutting off access. Question 21. By evaluating the impact of Gaia OS limitations, Delgado observes a security gateway crashing under high connection volume. He suspects an issue with kernel memory exhaustion and wants to verify connection table limits and allocation. What is the correct command to perform this diagnosis? A. Run netstat. None. Monitor socket count growth. B. URL ostat to observe memory pool allocations for the connection's kernel module. C. Use cat problem info to check system swap utilization. D. URL fitty. L to verify CPU core allocation. Answer. Correct answer. B. Explanation OELS that shows detailed stats about kernel memory allocations, including connection tables and sync memory. It helps identify if memory pools are near exhaustion. Netstat A shows TCP sockets but not kernel allocations. Problem info C shows system memory, not firewall-specific allocation. OEL fitted D shows EPU bindings, not memory. Kernel memory exhaustion is best diagnosed using PSTER. Question 22. Throughout the course of VPN troubleshooting, Yamamoto investigates intermittent IPsec tunnel drops, like Phase 1 completes, but Phase 2 fails with. And no matchings are found, where logs reveal overlapping encryption domains due to route-based VPNs. What is the most effective long-term solution? A. Reboot the peer gateways after clearing all tunnels. B. Use domain-based VPN with MP groups to eliminate conflict. C. Configure VPN domains explicitly and avoid overlapping networks. D. Disable VPN acceleration features in SecureXL. Answer. Correct answer. C. Explanation. IPsec Phase 2 failures due to overlapping encryption domains are best resolved by ensuring explicitly defined non-overlapping VPN domains. Rebooting it may temporarily fix it, but doesn't address configuration. Empty groups B are useful for specific bypasses, but can be unsafe. Disabling acceleration D doesn't affect Phase 2 negotiations. Clearly defined, separate encryption domains eliminate ambiguity during IPsec setup. Question 23. When presented with inconsistent log delivery, ISTA backend notices that log messages from multiple security gateways are delayed in SmartView Tracker. Upon investigation, EFAIR-DD is running on both gateways and the management server. What could be the most likely root cause? A. The log indexing process on the management server is failing to pass messages quickly enough. B. The log server is operating in legacy mode instead of ECP. C. SecureXSOL is bypassing logging for performance. D. There is a misconfigured NAT policy on gateways. Answer. Correct answer A. Explanation. If logs are delayed, it's often due to the log indexer failing to keep up with high log volume. This affects visibility in SmartView Tracker and SmartLog. Legacy B could cause drop logs, but less often delay. SecureXSOL C doesn't suppress logs unless specifically configured. NAT D affects traffic forwarding, not log passing. High discount or CPU on the management server can further exacerbate this issue. Question 24. The validity of the CoreXSOL configuration becomes evident when ISTA Syncer notices only one CPU core handling all firewall processing, despite CoreXSOL being enabled. He wants to confirm if CoreXSOL dispatchers are active. What should he do? Activity or affinity? V. Offer affinity mapping of interfaces. B. Use top to observe core usage patterns. C. VCP config settings to ensure CoreXSOL is enabled. UAE multi-stat to verify CoreXSOL dispatcher threads. Answer. Correct answer D. Explanation OEM multi-stat reveals active dispatcher threads and instances, which shows whether CoreXSOL is distributing the load across multiple cores. Affinity mapping A show EPU interface binding, not dispatcher activity. Top B is useful but not CoreXSOL specific. CP config C shows the feature status but not operational state. For real-time dispatcher visibility, multi-stat is the right tool. Question 25. Taking into account NAT traversal logic is mono configures hide NAT for several internal hosts behind a security gateway. However, external replies are intermittently dropped. What is the most probable cause of this behavior? A. Hide NAT is applied after the routing decision, creating mismatched sessions. B. The NAT table has reached its limit. C. Source port is being randomized, breaking protocol stateful tracking. D. IP spoofing protection is misidentifying the native packets. Answer. Correct answer D. Explanation. Spoofing protection on the external interface might see the native internal IP as invalid, especially if anti-spoofing groups aren't correctly defined. Option A is incorrect as NAT happens before routing. NAT table limits B usually result in system errors, not sporadic drops. Port randomization C affects some protocols but not general traffic. Updating interface spoofing definitions resolves this. Question 26. In the absence of synchronized kernel tables, Ista Johnson observes that a clustux or Harpay intermittently drops established connections during failovers. Logs show missing session table entries on the secondary member. What can you do to prevent this behavior? A. Use FAPROB sync stat to verify full synchronization before failover. B. Set the backup to accept all traffic unconditionally during failover. C. Enable SecureXSOL sync mode to distribute session state. D. Configure SmartLog to mirror logs to both members. Answer. Correct answer A. Explanation. Failovers require the session state tables connections NAT to be fully synced using CFAPROB syncs that confirms this. Without sync, the secondary may not recognize established sessions and will drop them. Accepting traffic unconditionally B bypasses security. SecureXSOL sync C is limited in scope. Logging mirroring D does not affect connection state. The best practice is to always verify synchronization before performing a manual failover. Question 27. Contrary to popular belief, disabling acceleration is not always beneficial for troubleshooting. Is Ibrahim disable SecureXSOL to trace a packet path? However, the packet still bypasses our inspection points. What is A valid reason for this behavior: A. The packet is using a Layer 2 multicast protocol. B. Coaxial overrides all packet inspection by default. C. Traffic is managed by a fast path route in the routing table. D. Inspection settings in the threat prevention policy are disabling kernel logging. Answer. Correct answer A. Explanation. Multicast and certain Layer 2 protocols do not pass through all FWNSA inspection points. These are handled differently in the OS and may bypass expected chains like EO. Coaxial B. Doesn't skip monitoring. Routing table behavior. C. Doesn't bypass chains. Threat prevention. D. Affects logging, not monitoring. When packets are multicast or Layer 2 broadcast, monitor outputs may appear incomplete. Question 20. The traditional approach to VPN debugging often fails with complex overlapping domains. ISTA-WU attempts to bring up Airbus sees invalid ID errors during phase 2. Which step best addresses this problem? Disable NAT traversal globally. B. Check encryption domain definitions and make sure both sides agree. C. Disable SecureXL to allow for proper ESP inspection. D. Force permanent IPsec tunnel to override phase 2. Answer. Correct answer B. Explanation. Invalid ID errors typically indicate mismatches in the encryption domain. G. Local remote subnets not aligned. Option A may cause new issues. SecureXL. C. Doesn't impact phase 2 IDs. Permanent tunnels. D. Don't solve domain mismatch. Proper VPN function requires symmetrical domain definitions on both pairs. Question 29. Focusing specifically on daemon behavior, Istatran said Aloe-rashing repeatedly after pushing a new policy containing dozens of nested inline layers. Which of the following actions is most effective for root cause diagnosis? They check smart log for last successful policy push timestamp. B. Use D. Debug mode to analyze compilation failures. C. Clear sick and reinitialize between management and gateway. D. Reverse pista ASAP to reload daemons. Answer. Correct answer. B. Explanation. D runs the policy installation with full debugging and is the best method to trace where the compilation fails. Smart logger shows symptoms, not cause. Sick reset. C is unnecessary unless trust is broken. Restarting daemons. D may help temporarily but doesn't reveal the root issue. Nested layers can lead to parsing or memory issues during compilation, best seen in debug output. Question 30. In response to unexplained CPU spikes, Isfera observes high EPU on certain cores but real fitty shows no binding issues. Suspecting soft ERK saturation, she wants to verify ERK distribution. Which approach is best? A. Analyze procs of TERKs and compare with CPU core mappings. B. Reboot into single user mode and run diagnostics. C. Disable hyper-threading in BIOS and retest. D. Usually debug to find application level causes. Answer. Correct answer A. Explanation. Soft ERK imbalance can cause performance bottlenecks on specific cores. Reviewing procs of ERKs provides visibility into how interrupts are handled and whether they're concentrated on one CPU. Rebooting. B is not diagnostic. BIOS changes. C are extreme and often ineffective. D is for kernel level drops, not CPU interrupt analysis. ERK misalignment is a key cause of unear CPU load.